Hello everyone. Let's continue our course. In the live network, we have a lot of handover happened between different eNoB. From the source eNoB handover to the target eNoB. The source cell and the target cell, they belong to the different eNoB. This kind of handover we call inter-eNoB handover. For the inter-eNoB handover, we have two types. One is X2-based inter-eNoB handover. Another one is S1-based inter-eNoB handover. If two different eNoB, they already have the X2 interface, and we hand over between these two eNoB, then this kind of handover we consider as X2-based inter-eNoB handover. Otherwise, if these two eNoB, they don't have X2 interface, then this kind of handover we call S1-based inter-eNoB handover. First, let's discuss the inter-eNoB X2 handover procedures. Also, here at the beginning, the original eNoB will send the measurement control message to the UE. Tell the UE how to perform the measurement. Here, this measurement control message includes the neighboring cell configuration and also the criterion for the measurement. After UE receives this measurement control message, UE will start the measurement on the neighbor cells. After some neighbor cells reach the criterion, UE will send the measurement report. Here, this measurement report including the target cell physical cell ID. Send the report to the eNoB. And once the eNoB receives the measurement report, then we will start the handover preparation procedures. From here, eNoB received the measurement report. Then eNoB will send handover request to the target eNoB through the X2 interface. Because these two eNoB, original eNoB, also we call it source eNoB, and the target eNoB, they have the X2 interface. So we can send the message to the target through the X2. This handover request is used for informing the target eNoB. There's a handover. There's one user who wants to hand over to the target eNoB. Inside the handover request message, we can see many information. For example, the target cell. For example, the services set up by the user, the ERAP ID, and the QoS information of the services, and the MME S1AP UEID, and the SGW IP address, and also the RRC context informations, some layer 3, layer 2, some parameters. The handover request message to send to the target eNoB. Then the target eNoB will know some user will hand over to his area. The target eNoB will start the admission control procedures. The target eNoB will check if there is enough resource for these new users. From this point, the target eNoB will check the remaining resource. If the target eNoB have enough resource, the target eNoB will send the handover request ACK to the source eNoB. If the target eNoB doesn't have enough resource to accept this new user, here the handover request will be rejected. After the source eNoB receives the handover request ACK message, which means the handover preparation procedures is finished, success. Then the source eNoB will start the handover performance. The source eNoB will send the handover command to the UE. This handover command, like the intra-eNoB handover command, RC connection reconfiguration. Here, RC connection reconfiguration, this message including the target cell ID, also including the new CRNTI allocated by the target eNoB, also including some PRAG config parameters like the preamble index, and also include the physical channel config parameters, and also include some security algorithms. All of this information is about the target cell, and this information is given by the target eNoB. Because during the handover preparation procedures, the target eNoB will check the remaining resource. Also, the target eNoB will forward the target cell's information to the source InnoB. And the source InnoB will send this message to the UE through the handover command. This information, these parameters related with the target cell and the target InnoB is very important for the UE when UE perform the handover procedures. After UE receives the handover command with all of these parameters and the information which related with target cell, then UE will start the handover procedures. UE will disconnect with the old InnoB and build a new connection with the new InnoB. And at the same time, the source InnoB will send SN state transfer to the target InnoB. Here, SN state transfer, which means serial number state transfer. Serial number is the serial number for the packet, for the traffic. Because the traffic and the data is sent to the source InnoB. The source InnoB will forward the traffic to the target InnoB through the X2 interface. So the source InnoB must tell the target InnoB from where the target InnoB should continue the services. What is the serial number of the packet? For example, UE download a file from the source cell, from the source InnoB. When the UE finished 50% of the downloading at the source cell and the handover happened, UE must continue the rest of the 50% of the downloading at the target cell. We must tell the target cell from where we continue this, from 50% or 60%, from where we can continue our services at the target cell. And this serial number actually is very important for our services. And as we can see, this kind of color, the red color shows the user data. Here, after the source InnoB send the SN state transfer to the target InnoB, then also at the same time, the source InnoB send the data to the target InnoB, forward the data, downlink data to the target InnoB. And meanwhile, UE will perform the random access procedures to the target InnoB. Here, as we can see, random access preamble sent from the UE to the target InnoB. And the target InnoB will send the RA response to the UE. This random access procedures actually is the non-contention based random access procedures. Because during the handover preparation procedures, the random access preamble and the random access time slot is predefined by the target InnoB. And the target InnoB tell all of this information to the source InnoB through the handover ACK message. And UE finally will send the handover complete message to the target InnoB. If the target InnoB receives this handover complete message, which means handover is a succeed, handover is a finish. But actually, we must change the path after the target InnoB receives this handover complete. Because in the downlink, the traffic still go from the core network to the source InnoB. We must change the path. Let the core network know the handover is finished and complete. Let the core network change the path from source InnoB to the target InnoB. After this path switch, the downlink traffic will be sent from the core network to the target InnoB directly. So the target InnoB send the path switch request to the core network. And the MME, SW, they will change the path by these two messages, modify barrier request and modify barrier response. After this, MME will send path switch request ACK. Tell the target InnoB, core network already know the handover is finished and the success. Core network will change the path, and the path switch is succeed. After target InnoB receive the path switch request ACK, the target InnoB will send the UE context release message to the source InnoB. Until now, until source InnoB receive UE context release message, the source InnoB finally know the handover is a succeed and complete. In this message, the target eNoB will tell the eNoB the handover is a succeed or failed. If handover is a failed, in this message, the target eNoB will inform the source eNoB what is the reason for the failure. After this message, UE also will perform the TAU procedures in the target cell. Okay, this is all the signaling flows for the handover procedures. Here, the blue color indicates the layer 3 signaling, and the black color indicates the layer 1 and the layer 2 signaling. The red color shows the user data directions. Here, the blue color is very important for us to understanding the handover procedures. And here, this is examples for the tracing case of the inter-eNoB X2 handover, especially for the RC connection reconfiguration message. RC connection reconfiguration message is a handover command. Inside this message, we can see many key information. For example, the PCI of the target cell. Tell the UE which cell UE should hand over to, and the frequency of the target cell, and the bandwidth of the target cell, and also the new CRNTI for the UE, and also the security algorithms parameters used in the target cell. All of this information is related with the target cell. We tell this information to the UE. It's used for the UE. And all of this information is very important for the UE to perform the handover procedures. And these pictures shows the S1 handover procedures, because we know for the inter-eNoB handover, we have X2-based handover and S1-based handover. If two eNoB, source eNoB and the target eNoB, if they don't have any X2 interface, then the S1 handover will be happened. But S1 handover almost same with the X2 handover. It's just one different. Source eNoB cannot send the signaling directly to the target eNoB. We must need the assistance of the core network. First, source eNoB send the message to the MME. Through the MME, MME will forward the message to the target eNoB. MME here is just like a bridge between the source eNoB and the target eNoB. If source eNoB and the target eNoB, if they want to send any message between each other, they must use the help of the MME here. The signaling is almost the same with X2 handover. Let's focus on the blue color here. First, source eNoB send the measurement control message to the UE. UE will start the measurement on the neighbor cells. If the neighbor cell match the criterion, UE will send the measurement report to the original eNoB. And the original eNoB also will send the handover request, handover required here, to the target eNoB. But here, the handover required is sent to the MME and the forward by the MME. Finally, handover request reach to the target eNoB. And at this moment, the target eNoB will start the admission control, check the remaining resource to see if it is enough for the new user or not. If target eNoB have enough resource, the target eNoB will reply handover request ACK to the MME, and also MME will forward this ACK to the eNoB, source eNoB by handover command message. If source eNoB receive this handover command message, source eNoB will send the RC connection reconfiguration to the UE, which is a handover command for the UE. And also, source eNoB will send the SN state transfers to the MME. And all of this actually is the handover preparation and the handover perform procedures. Exactly same with the X2 handover. Here, after the SN state transfers, at last we will have the handover completion procedures. UE will perform the random access in the target cell, and UE will send the handover complete message to the target cell after the random access procedures. And also in the target cell, target InnoB will send handover notify message to the MME. Here, this handover notify message is just like the pass switch for the X2 handover. For the X2 handover, we use pass switch signaling. But here, for the S1 handover, we use handover notify message. But actually, they are the same. Same functions, same purpose. And the MME and the SW, they will modify the barrier and change the path from source InnoB to the target InnoB. After the pass switch is finished, the MME will send this message to the source InnoB, UE context release command. Tell the source InnoB the handover is succeed or failed. If it is failed, what is the reason for the failure? And the source InnoB will send this context release complete message to the MME. And all of this is the procedures for the S1 based handover. Let's have a summaries for these chapters. First, we discussed the intra-InnoB handover procedures. Then we discussed the procedures for the inter-InnoB X2 based handover. If two InnoB they have X2 interface, we will perform these handover procedures. And at last, we discussed the inter-InnoB S1 based handover. That's all for these chapters. Thanks for watching.